using factoring is one way that we can solve a quadratic equation, something with x squared in it. Notice this time our problems are not expressions, they are now equations, they have an equal sign in them. So our directions will change. It's not going to say factor anymore, it's going to say solve. Or you may see something like find the roots, or in a few minutes you'll see find the zeros. All these words and terms mean we're going to go further than just factoring. So the biggest thing we want to make sure when we start is we have to be equal to 0. If you're not equal to 0, don't even bother factoring because it's not going to be helpful to you. So we are equal to 0 in these first couple of examples, so let's just go ahead and factor using the skills we have worked on already. So I have a trinomial where my a value is 1, which means I can factor this by finding two numbers that multiply to negative 36 but add up to negative 5. And so make your list of factors either in your head or on paper if you need to. I know that since I have a negative product, I know I have one positive sign, one negative sign. The factors that are going to work this time must be a negative 9 and a positive 4. Those multiply to negative 36 and add up to negative 5. Now at this point in the past we'd be done, but no more, because now what I'm trying to do is solve. And the reason I wanted to be equal to 0 was this. What I've got are two things being multiplied together, and I see that those two things multiplied together gets me an answer of 0, which tells me the only way to multiply and get a 0 is for one of those two things to be equal to 0 themselves. So either x plus 4 has to equal 0 or x minus 9 has to equal 0. Because if one of those parentheses is 0, it doesn't matter what the other one is, the entire product will be 0. That's the key to solving by factoring. So if I solve each of these little equations then, I get two answers. I get an answer of x equals negative 4, that's a solution to my quadratic equation. Or if I add 9 to both sides, I can get 9 as a solution as well. Now it turns out that those two values are special. If I were to graph this parabola, and you may want to do this, maybe pause the video and graph this parabola, what you'll see is, you'll see that negative 4, and I'm not going to count all the slashes, positive 9, those are going to be the two spots where the parabola crosses the x-axis. So negative 4 and positive 9 are the two spots where that graph would cross the x-axis. So that's why we're getting two solutions. So a great way to go back and get a visual confirmation of your answer would be to graph as well. But let's keep going with the solving by factoring. So again, we have to be equal to 0. We are in this second example. So I need two numbers that multiply to positive 4 and add up to negative 4. This time those numbers are going to be x minus 2. And another x minus 2. And once again, because we have that equal sign, or because our direction's set to solve or find the roots or find the zeros, I'm not done once I've factored. I have one more step to do, and that's to put each factor equal to 0. So once I solve each of these, I come up with an answer of 2 and a second answer of 2. One thing we'll be seeing throughout this unit is that we're always getting two solutions. Sometimes it may be a double solution, like in this case, or sometimes we may even be dealing with imaginary answers, which will be coming up a little bit later. But once again, those x-intercepts represent, or those solutions represent x-intercepts. If you were to graph this, our x-intercepts, the only one we have is at positive 2. You may be wondering how a parabola could only intersect the x-axis twice, or maybe you're not wondering, maybe you know, but if you graph it, you'll see what happens. The only way a parabola could just touch the x-axis once is if it's the vertex. So that's what happens in this double solution case. Our parabola comes down and just the vertex intersects at negative 2. Okay, let's do one more of these before we switch things up a little bit. Again, you want to be equal to 0. If you're not equal to 0, don't even bother factoring. So first thing first, let's make this equation equal to 0. To do that, I can just subtract 54 from both sides. And now once I'm equal to 0, now I'll go ahead and factor. So two numbers that multiply to negative 54 but add up to negative 3. Again, I know I'm going to have opposite signs. One will be positive, one will be negative, and I believe the factors that are going to work are going to be a negative 9 and a positive 6. Should be the combination that works. I want to go one step further. Since I know two things are being multiplied together to equal 0, what I know is one of those two things must be 0 themselves. So either z plus 6 is 0, or z minus 9 is 0, and solving each of those gets me my two solutions. So one solution of negative 6, and if I graphed the parabola, I would see that that was also the x-intercept. If I add 9 to both sides, another solution is z would equal positive 9. Sometimes I may also be asked to find the zeros instead of the roots or instead of solving. All these things basically mean the same thing. Whether they say solve it or whether they say find the zeros, find the roots, find the x-intercepts, they're all pretty much the same idea. And for now, we're going to stick with factoring to solve all these problems. Although, as we've talked about, you could graph and find the x-intercepts. Let's stick with solving by factoring. So these problems look a little bit different, but we're going to treat them the same exact way. Whether they give you an equation or a function, like with a y or with f of x, all I want you to do is just go ahead and make that 0. So just set the whole thing equal to 0. Same thing over here, just make that f of x equal to 0, and then solve like normal. So I'm going to pause the video so you guys can try these. Otherwise, if you want to just let it play through, I'll have my work pop up. But we're doing the same thing we just did. Set it equal to 0, factor it, and then put each factor equal to 0 to get your two solutions. So there you go. There's our solutions. If you didn't get those, ask me a question in class. And then once again, those those values, remember, represent x-intercepts. So if you were to graph your parabola, you'd see that that's where the graph crosses the x-axis. On the second example, where we had the same solution twice, remember that would represent the vertex of the parabola just coming and skimming the surface of the x-axis before it bounces back up. And then finally, we'll take a look at solving when we need to use the box method. So our a value is no longer 1. The same thing still applies. We're setting it equal to 0, factoring it, and then putting our factors equal to 0. So we'll see equal signs now, equations. They may ask us to find the roots, the zeros, the x-intercepts. They all mean we factor it, but we go one step further. So we're looking for a greatest common factor. In this first example, I don't have one. So since the a value is not 1, I'll go right to the box method in order to factor this. First term goes in the first box, last term in the last box. I need two numbers that multiply to negative 24 and add up to 10. Be careful on this one. This one tricks a lot of people. I'm going to make my list of factors. 1 and 24, 2 and 12, 3 and 8 could work, 4 and 6 could work, and that's my complete list. Be careful. A lot of people are tempted to jump right at 6 and 4 because they add up to 10. But remember, since we want to multiply to something negative, I need opposite signs. So making one of those signs positive and negative, that won't work. Instead, the combination I do need is going to be up here, positive 12 and negative 2. So let's get those in the box. Doesn't matter where they go. Just make sure they have x's with them. And then to do your factoring, look across rows and columns for things they have in common. Be careful, I see this mistake a lot too. People will take out a 2 down here, for example. It's true they have 2 in common, but there's something bigger, and that's 4. So make sure you take out the greatest common factor. Go up and down columns. So a 3x and then a negative 2 matching signs on the outside. Meaning my factors are 3x minus 2 and x plus 4. Now I'm not done, I factored it, but because we're doing these new problems where we're solving, we have one more step to do. Since I know two things are multiplied together to equal 0, I know that either x plus 4 equals 0, or I know that 3x minus 2 is equal to 0. One of those two parentheses must be 0 if the entire product is 0. So one solution is just negative 4. The other side, if I solve this little equation, I've got 3x equals 2 once I add, and then dividing by 3 gets me an answer of 2/3. So yes, you are going to start to have fractions and decimals for these box method problems. Deal with it, is all I have to say. Okay, let's do one more of these. It looks really nasty, but watch how easily this one works out. I need to be equal to 0, so if you're not equal to 0, don't even bother factoring it until you're equal to 0. So to start, I'll add or subtract 4p and add 5. I want to get everything moved to one side. So I'll subtract 4p there, add 5 right there. I've got 5p squared minus 20p, and then plus 20 equals 0. Looks like the box method, but don't forget to check for a greatest common factor. I have one this time. It's a 5. So once I pull a 5 out, divide everything by 5, I can see that I don't even need the box method. There's no longer a 1 in front in the parentheses. So I can factor the old way, where it's just what multiplies to 4 and adds up to negative 4. And that's a negative 2 and a negative 2. And then don't forget your GCF in front. So there's my factored problem. It's completely factored. I'm going to do what I've done in the past, put each factor equal to 0. Either p minus 2 equals 0 or p minus 2 equals 0. And some people aren't sure what to do with that 5, so I'm going to draw a line. Technically that 5 is a factor as well. So people think, well, is 5 a solution? We said we'd only get 2 solutions. and I can see there's my double solution, P is 2. So what's that 5 do? Well, do what you've done over here. Put every factor equal to 0. So I can write 5 equals 0, but 5 never equals 0, so that doesn't get you any solutions. You won't get solutions where there's no variables, so the only solutions are the double solution of P equals 2.